Is it likely that particle physicists working at the CERN facility near Geneva, Switzerland, which houses the Large Hadron Collider, have opened a gateway or tunnel to, say, another dimension? Could they be gaining access to a distant world orbiting two stars in a galaxy inhabited by Marvel heroes? Perhaps they have opened Europe's door to a flaming domain full of demons, or even worse, to a nearby black hole in our universe. Watch this video till the end to find out. Before we tell you the secret about the gateway or portal to another dimension, let us first inform you about CERN. CERN is an acronym for the French Conseil Européen pour la Recherche Nucléaire and is located on the Franco-Swiss border. It is formerly known as the European Organization for Nuclear Research. CERN may be unfamiliar to you, although the organization has been in existence for quite some time. The organization, which was founded in 1952, is known for conducting world-class physics research with an emphasis on understanding the atom. It is the world's largest particle physics lab and home to the world's largest accelerator, the LHC, or Large Hadron Collider. The LHC, built by CERN between 1998 and 2008, is the world's largest particle collider, contained in a 17-mile circumference tunnel sunk up to 175 meters underground. What exactly does it do? It accelerates high-energy particle beams to near light speed, where they collide at 4 points. The goal is to address some of the most fundamental questions in physics, ranging from the connections between subatomic particles to theories of space and time, the Big Bang, as well as Einstein's theory of relativity. The discovery of Higgs Boson, popularly known as the God particle, in 2012 was a defining moment for the LHC. Before the Higgs boson was discovered on July 4, 2012, physicists had a theory but no proof for how fundamental particles such as electrons and quarks gained their mass. Such was the frustration that Leon Lederman, a Nobel Prize-winning physicist, wanted to title his 1993 book on the subject, The Goddamn Particle. If the universe is the answer, what is the question? Sensing that this would be too controversial, his publishers changed it to the God particle. The Higgs boson is the fundamental force-carrying particle of the Higgs field, which is responsible for granting other particles their mass. This field was first proposed in the mid-60s by Peter Higgs, for whom the particle is named, and his colleagues. According to CERN, the Higgs boson has a mass of 125 billion electron volts, which makes it 130 times more massive than a proton. It is also chargeless and has no spin, which is the quantum mechanical counterpart of angular momentum. The Higgs boson is the only elementary particle that does not have a spin. Detecting the Higgs boson isn't just a question of setting up a detector and waiting for one to come along. These particles only existed in the high-energy conditions of the early universe. That means that before this particle can be detected, these high-energy settings must be replicated, and Higgs boson must be created. The LHC does this by speeding protons to near light speed and colliding them. This results in a cascade of particles that decay quicker into lighter particles. Because the Higgs boson decays too quickly to be detected, it was discovered by detecting particle decays that indicated a particle with no spin and matched theoretical expectations for this missing boson. By revealing this particle, predicted by the Standard Model, the discovery of the Higgs boson completed this picture of the subatomic world. There are still unanswered questions beyond this hypothesis, such as the nature of dark matter, which the Higgs boson's unique qualities may assist to solve. What is dark matter? According to our understanding of the universe, all the atoms and light in the universe together make up less than 5% of the total contents of the cosmos. The rest is composed of dark matter and dark energy, which are invisible but dominate the structure and evolution of the universe. Dark matter makes up most of the mass of galaxies and galaxy clusters and is responsible for the way galaxies are organized on grand scales. Dark energy, meanwhile, is the name we give the mysterious influence driving the accelerated expansion of the universe. What these substances are and how they work are some of the major challenges facing modern astronomers. Some scientists at CERN hope the LHC will uncover evidence of dark matter. Now let's speak about those portals and dimensions everyone's talking about. In 2016, eerie clouds over Geneva were captured in a series of photos, just 10 days after scientists reactivated the LHC. People were quick to believe that the jaw-dropping photos were proof that CERN was opening a portal to another universe. Were the scientists at CERN genuinely looking for universe secrets, or were they opening hell's portals? Fast forward to today, and people are still claiming that something else is going on at CERN. The LHC opened up again earlier this year after 3 years of upgrades and maintenance work. Beams have apparently been circulating in the accelerator since April and are now stable enough to continue testing at higher energy levels than ever before, with a runtime of over 4 years. As a result, there is widespread panic on social media. The Hadron Collider itself is the subject of numerous conspiracy theories. Many speculations have emerged concerning the real experiments being undertaken within the collider as a result of the machine's sensationalism. After an earthquake in April 2016 coincided with the collider's rapid closure, many people decided that something weird was going on beneath Switzerland. One Twitter user wrote, "CERN is opening a multi-dimensional portal on July 5 and will be using dark matter." Some feel that the tests are opening doors to other dimensions, universes, or just the past. These theories, while strange and probably far-fetched, are not wholly without merit, especially given that some experiments conducted inside the collider may prove the existence of other universes. So why not a portal to them as well? Whether it is through the portal or some other strange way, people have theorized that scientists are actually using the LHC to summon God or its evil counterpart, Satan, and demons along with it. This one is possibly the strangest. Whether they are trying to prove the existence or summon them for some ulterior motive, the theory may be the most far-fetched, but that might be the point. It could be the last thing we expect scientists to be searching for is exactly what they are searching for. Let's put conspiracy theories and speculations aside and dig down into what CERN is all about. If we're talking about a kind of tunnel that human beings and the like could move through, then there's a big obstacle in the way. That obstacle is the rigidity of space itself. The concept of a wormhole, a sort of tunnel in space and time that could allow you to go from one part of the universe to another without traveling the most obvious route, or possibly to realms where there is no other way to get there, isn't altogether crazy. The mathematics of Einstein's theory of space, time, and gravity allows it. However, the concept is riddled with both intellectual and practical challenges. At the heart of all of them, there's a basic and fundamental problem. Bending and manipulating space isn't easy. The amount of energy needed to bend space into a new shape can be massive. For example, if we want to have an approximate idea of what it takes to create a wormhole with an exit the size of a doorway, we can ask what it takes to create a black hole of that magnitude. A black hole the size of a doorway would have a mass similar to Saturn, which is 100 times greater than our own planet. While CERN's electrical budget is large, you'll burn through it quickly. There's not that much energy on Earth, or even in Earth. Even if you magically converted the Earth's entire rest mass via E=mc² into the energy of 2 beams of particles and funneled the 2 beams into a small place all at the same time, you still couldn't even make a human-scale black hole. Is there another approach? Sure. All we have to do is obtain a Saturn-sized planet and shrink it down to the size of a dinner table. These black hole problems are horrible enough, but at least we know that nature does create large black holes. There is no evidence that nature has ever created a wormhole through which you could travel, and it is unclear how humans could create one in principle. Furthermore, if scientists were to create one, it would be extremely difficult to control. In science fiction, portals sit on the ground, waiting for you to walk through them. A wormhole, on the other hand, is significantly less friendly, with no intention of staying put on the Earth's spinning surface, and with no qualms about ruining your laboratory and a lot more all around it. A human-sized doorway to somewhere else would represent a risk to the entire planet's present and future, so you'd have to store it far away in distant space. But even if we can't have large wormholes, how about a virus-sized wormhole? Maybe scientists can make those. Even in the most hopeful scenarios, creating a black hole the size of an atom, far too small for a virus, is far beyond CERN's capabilities. The large amount of energy would have to be concentrated all at once into an atom-sized region. While CERN's proton beams contain as much energy as a freight train, that energy is distributed over 17 miles on the circular tubes that comprise the Large Hadron Collider. It's not squeezed or squeezable into an atom-sized box. What CERN can actually do with its beams doesn't even come close to what is needed. In science fiction, you can be reckless with space, but in reality, space will not bend to your will. Rest assured, CERN scientists are not making literal portals to anywhere. In the end, it seems like CERN has everything under control. Their experiments recreate conditions that happen in nature all the time, and the world is still standing. The only difference is that the laboratory conditions are carefully controlled and observed. What do you think? Let us know in the comments section below.